Good morning or afternoon or evening, whatever time you're working on this. It's Mrs. Blankenbeckler, and I'm talking about lesson 801, Quadratics. All this should be review for you. So I hope it's really quick, down, dirty, and I'm going to go through it pretty quick because it is review for us. Okay, the first thing, and I am going to refer back to the LMS, and I'm going to tell you to pause, go look at some screens, and then come back, and then we'll do examples. But the first thing you need to do is remember how to factor. So that's what we're going to do first. So I'm going to throw up some problems very quickly and see if you guys can factor those. That one's not a good pen. I thought it was, but it's not. Okay, x squared minus 9. How does that factor? Pause, factor it. Okay, the answer is x plus 3x minus 3. The difference of two squares. Okay, so that's factoring difference of two squares. How about this one? How would you factor x squared plus 3x minus 40? Okay, sorry, I'm making these up as I go along. Okay, what multiplies 40 has a difference of 3. That's what you ask yourself. Let's see. 40 is 1 and 40, 2 and 20, 3 doesn't go, 4 and 10, 5 and 8. Bingo, 5 and 8. Those are the magic numbers. 5 and 8 have a difference of 3. This has to be a positive 3, so I need a positive 8 and that negative 5. Back end is negative. That means the signs are opposite, one positive, one negative. If the back is positive, they're the same sign, and this is the clue. But since this was negative, we knew we had one positive and one negative to get a negative 40. Okay, let's try another combination. How about x squared minus 10x plus 21. Okay. There is one that has a back end that is positive. That means both signs are the same. They have to add to 10. What two numbers add to 10 but multiply to 21? You can pause and check, but the answer is 7 and 3, right? 7 and 3, and it's minus, minus, because they both have to be the same sign and they both have to add to negative 10. So it's x minus 3, x minus 7. So that's how that one factors. Now there are some that you are going to need to factor that have GCFs. What's a GCF? Greatest common factor. Okay, greatest common factor. For example, if we have 2, and I can't find a decent pen for you guys today. See if I can shake this down. 2x squared minus 6x, let's see, plus 8. Let's just try that one. Okay, what's my common factor? It is a 2, so just take a 2 out. And we're left with x squared minus, divide that by 2, 3x plus 4. Now we have to, what multiplies to 4 but adds to 3? What multiplies to 4 but adds to 3? See, 4 and 1, those don't add to 3 though, they subtract to 3. 2 and 2, those two add to 4, subtract to 0. So this trinomial is prime. You can't factor it any further and you are done. So that's a quick, down, dirty. Let's review factoring. Now, you need to know factoring because we were just factoring quadratic equations. How do we know it's quadratic? Because it has an x squared, right? It has a square. So we are going to look at 2 different forms of a quadratic today. The first form is standard form. Okay, what's standard? It is ax squared plus bx plus c equal 0. That's my standard form, where a is the coefficient to the x squared, b is the coefficient to the x to the first degree, and c is our constant. So you can remember c stands for constant, and it's set equal to 0. So that's the standard form of a quadratic formula. Now, there's some information we can get out of this formula by using a couple of quick little mini formulas. The first one is the vertex. Okay, we already know what the graph of a quadratic looks like. It's a parabola. It's a curve facing up, or it's a curve facing down. So we can find the vertex, which is either the maximum point if it's facing down, or a minimum point if it is facing up. That's the vertex, right? At the very top, or this is the top and this is the bottom of the graph. So what's the formula for that that vertex? To find the x coordinate, all we do is use negative b over 2a. That's how we get the x coordinate of it. So let's throw in some numbers. What if we have 3x squared minus 6x plus 9? Okay, there's our formula in standard form. A, B, C. We're going to take negative, or the opposite of B. So right now B is negative 6. So the opposite of B would be positive 6. All over 2 times A. Well, A is 3. So 2 times 3 also gives me 6. So 6 over 6 is 1. Okay, so that means the x coordinate of my vertex, so if I'm looking at the graph, the x coordinate is going to be over here at the number 1. Okay, now, how do I get the y coordinate? I just plug it back in, don't I? I just go back and plug in x, and I get out my y coordinate. So, 3 times 1 squared. Well, that's just going to be 3. 3 minus 6 times 1, because I got to plug in my 1 there also, plus 9. So 3 minus 6 is negative 3. Negative 3 plus 9 is positive 6. So that means my vertex is going to be at the ordered pair 1, 6. And that's how I get my vertex. So in the LMS, it says to find f of negative b over 2a. That looks confusing. All that means is plug in your answer. Whatever you get your answer here, plug it into the equation to get out your y. So that's hopefully a simpler way to think about it. Once you get the vertex, just plug it in. Okay, so in this case, we got 1, 6. So I'm going to go over 1, 6. There's my vertex. And we know about A, don't we? A, if it's positive, it faces up. If it's negative, it frowns and faces down. So A is a positive 3. That means my graph is going to face up. And voila, there is a general graph of where my vertex is and the facing of which way it's going. We're going to get a little more specific with that in a minute. Now, the one other item that I actually didn't think about, but it's in the LMS. If you plug in 0 for x, doesn't it give you your y-intercept? It does. So if you plug in 0 for x, A and B disappear and you're just left with C. So to find the y-intercept, all you do is plug in 0 for x, you get out y, but every single time the x, A, and the B terms are going to disappear. So C is actually your y-intercept. So that is another thing that's pointed out in the LMS, and you can go watch that lesson. So watch the first few parts of that. Then I want you to stop right now. I want you to view page 8 in lesson 801. It's a great page. It goes through the example, and it also talks about your axis of symmetry. Your axis of symmetry is the line that you can fold the quadratic formula on, and it's a vertical line. It always goes through the vertex, so it is going to be x equals, because it's x, because it's a vertical line, 1 in this case. It's going to be whatever the x coordinate of the vertex is. Okay, my time is up. So stop and view page 8.